Introduction to Data, Statistics, and Measures of Central Tendency. Clinical laboratory professionals analyze data to determine and validate patient results, track quality control and quality assurance, analyze reference ranges, evaluate critical result occurrences, and so much more. So what is data? Data is used to describe, measure, and evaluate phenomena, often to support decision-making, quality improvement, and research. Data can be quantitative or qualitative. Quantitative typically involves numbers. It's measurable and expressed as numbers. It can be used to perform calculations and statistical analysis. Qualitative data is descriptive and non-numerical. It often categorizes labels or characteristics and is used to classify information. For example, a person's blood type is A, or a test result is positive. So if we look at quantitative data, quantitative would be numerical. So we would say potassium levels in the blood are 4.2. Or we would say there are 12 patients that are positive for syphilis. Qualitative would more or less focus on the categories of characteristics. So this person's blood type is A, or test result is positive, not numerical information, it's just a result. When we do statistical analysis, we're really focusing on quantitative data. Examples in a clinical lab: blood glucose level is 105 mg per deciliter. White blood cell count is 7.2 times 10 to the 9 per liter. Turnaround time is 45 minutes. The number of tests performed per day is 1,200. There are two main types of quantitative data: discrete, which is whole numbers, so the numbers of patients, numbers of test tubes. So those are things that can be counted. And then you would say it's this many tests that were run, this many patients that were positive. Continuous are measurable values on a scale. For example, hemoglobin concentration. We can have varying levels of hemoglobin concentration, and those numbers are usually measured with decimal places. So the statistical analysis of data. Statistics is the practice or science of collecting and analyzing numerical data in large quantities, especially for the purpose of inferring proportions in a whole population from those in a representative sample. So we're trying to learn something about the population by evaluating the statistics of a sample within that population. A data set would be all of the numbers that will be analyzed using statistical analysis. A data point would be one number within the data set. Population is all of the numbers being analyzed. For example, the blood value for every patient that was seen by a particular clinic, or the blood value that was seen in patients in a particular region. Sample would be a subset of a larger population that is used to make inferences about the population. A sample is usually collected at random, so we would randomly pick certain patients to be in this sample. How they're selected is usually by blind random selection, because we don't want to have our own biases try to demonstrate something in the numbers. So an example, 177 patients tested positive for malaria, Plasmodium falciparum infection. To determine whether levels of pro-inflammatory cytokines increased or decreased during an infection, 59 patient samples were tested. 99% of the patients tested had an increase in pro-inflammatory cytokines. So a research study was published that stated there's an increase in pro-inflammatory cytokines during malaria infection. How many patients make up the population? Well, in this case, it could be 177 if we're looking at only positive specimens. In other cases, if we're looking at all of the patients tested, whether they were positive or negative, we would be talking about the entire population of patients seen. So every blood sample that would be received in the hospital, and that number wasn't given to us in the problem. So it all depends on what you're looking at in your research study. But when we're looking at this one, 177 is the population because we're only concerned about the positives in this study. How many patients make up the sample? 59. So why don't we test every single person in the population? The big reason is money and time. So a lot of times we don't have the time or financial resources to test every single patient. So what we'll do is randomly select a small subset of patients to do that deeper dive, that deeper analysis. And then we can apply what we learn about the sample that we collected to the entire population. Now you do have to select enough patients in order for it to reach what's called statistical significance. So what that means is you have to have a large enough number of patients that you test if you're going to start inferring things about the population. So if I have a population of 2,000 people and I test one person for what I'm looking for, and that one person happens to have a positive test, can I say that the entire population is positive? No, because I only tested one person within that population. We have to have enough people sampled in order to start making those inferences about the population. And that's where research studies that get published, you really need to look at how many patients were actually tested. Because in order to reach that statistical significance, we need a large number of patients tested, especially if we're going to be making inferences about a large population. So measures of central tendency. This gives us information about the data to see where the data is kind of at and what is the central point within the data. Mean. Mean is also known as the average. So this is the average of a group of numbers or an average of a data set. We use the mean value to perform other statistical analyses on the group. This is just one indicator of central tendency, and central tendency is the distribution of data around a central value. So I'm going to talk a little bit about the variables in these equations, but we can calculate the population mean if we have tested the entire population. For this class, we are mostly going to focus on the sample mean because we're taking samples from patients and a subset of patients are going to be evaluated further. So we really don't get into population statistics. If you take an advanced statistics class, then you'll definitely learn about the differences and you'll calculate them and you'll learn all the different variables. But this variable here, mu, refers to the average of the population, while the x with the line over it refers to the average of the sample. Since we aren't going to be focusing on population, I'm not going to cover too much more of this, but capital N is talking about the number of items in the population. So in this case, it would be like 100% of the people that were tested. But we focus more on sample mean. And the little n is the number of items in the sample. So looking at the equation, to calculate the mean, this big symbol is the sum of all of the little x's in the data set. So each one of these is talking about an independent data point. So we would take the sum of each one of the independent data points and we would divide it by the total number of data points that we have. So here's a sample problem where we're going to sum all the numbers in the data set and then divide by the total number of data points. So here's our data set. So basically what we're going to do is we're just going to add all of these together. And when we do that, put this in my calculator, 2 plus 3.7 plus 3 plus 1.9 plus 4 plus 2.2, we get 16.8. Now, that's the top part. So we have summed all of the data points. Now we have to divide by the total number of data points. So we have 1, 2, 3, 4, 5, 6 data points. So we're going to divide this by 6. And our mean is 2.8. So that is our answer for this one. If you look at the numbers here, our smallest number is 1.9, our largest number is 4.0. Does it make sense for our mean to be 2.8? Before you finalize your answer, you want to kind of make sure that your answer makes sense. And in this data set, yeah, it makes sense that the average would be 2.8. So another example, a student was performing a manual wet chemistry laboratory in which she obtained 5 replicate absorbance values for her unknown. What is the absorbance value for, or mean absorbance value for the unknown? So these were repeat tests. So the first time she did it was this value, the second time, the third time, the fourth time, the fifth time. So all of these times, this is what her average was for each individual attempt. So in order to calculate the mean here, you would have to add these all up and divide by the total number of values. So we would get 0.425 plus 0.43 plus 0.435 plus 0.432 plus 0.428. And we get 2.15. And we're going to divide that by the total number of samples, which is 5. And we get 0.43. Does that make sense? Yes, I would say that that makes sense based on these numbers. The median is another indicator of central tendency. It's the central number in a group of numbers when the numbers are arranged in sequential order. So we would actually put the numbers of the data set in order of increasing number, so smallest to largest. And the median would be the center number. An equal quantity of numbers is greater than the median value and less than the median value. So it's somewhere in the middle. It may or may not be the same number as the mean value. For example, student was performing manual chemistry. What is the median absorbance value for the unknown? Well, we're going to rank the number from lowest to highest. So 4.25 is the lowest, 4.35 is the highest. So then 4.3 would be the median. That's our middle value. In a set of values that contains an odd number of values, you're going to add 1 to the total number of values, divide the total number of values plus 1 by 2, and that will give you the number of the data point that is the median number. So this is kind of a complex description of how to find the median number. You would just go, what I do is in order from the top to the bottom. I kind of put my fingers on the lowest number and the biggest number, and then count inward toward each other until I get to the center number. The mode is the number that occurs most frequently in a group of numbers. For example, what is the modal number for the following group of glucose values? So 70 is the lowest, 76 is the highest. Are any of these numbers repeated? Yes, we have 2 72s. So because we have 2 72s, that would be the mode. Our mode for this data set is 72.